You are listening to podcast number 1 on naming. Today we will be talking about binary ionic naming. There's 5 different parts to naming that we'll be going over. This is the first one, but we'll also be covering naming with transition metals. We'll be covering naming with polyatomic ions. We'll be talking about naming with covalent compounds and naming with acids. Those are in the future videos. This is the naming portion for the level 1 Padawan Anakin part of the packet. So if you have your guided notes in front of you, go ahead and get to the level 1 Padawan Anakin portion, and the notes, you can follow along there. But last class, in class, we talked about the periodic table and the different components of the periodic table. So just a real quick review. In group 1 here, we have our alkali metals, and these all have a positive 1 charge, and that is shown above here. Positive 1 charge. In our second one, we have our alkali earth metals. These have a positive 2 charge. And if you come over to the middle part of the periodic table, more elements with a set charge is we've got silver, zinc, and aluminum. We call those our bing, 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 a 1, 2, 3, silver, zinc, and aluminum. So our silver has a positive 1 charge, our zinc has a positive 2 charge, and our aluminum has a positive 3 charge. So those are all of the ions, our metals that have set charges. That's what we'll be focusing on today. And then our nonmetals that we'll be focusing on are our negative 1 charged halogens, negative 1 charge, our negative 2 charged chalcogens, and then we've got nitrogen and phosphorus, which have a negative 3 charge. So we know our charged ions and cations. We've got our metals on this side and our metals in the middle and our nonmetals over here. So starting off, a binary ionic compound, which is what we'll be talking today, has a metal that has a set charge. So we're going to be talking about the metals in group 1, the metals in group 2, and our bing, bing, bing. That's what we're going to see today in our binary compounds. And then we will also be combining one of those with a nonmetal. So something from one of these 3 groups over here. So when we are naming a compound, we're first going to be given a formula, and we're going to have to write out a name. So if you look at our first example, we have Ki, and in the blank above that it says naming a compound, blank written first followed by the blank blank whose suffix is changed to "ide." So our metal is going to be written first, and if you look on the periodic table, K is over here on the left, number 19 on the periodic table. It's a metal, so that's going to be the first thing we're going to write, and K stands for potassium. That's an O. It's our metal, and written first followed by the nonmetal whose suffix is changed to "ide." So our nonmetal is I over here, and I is over in group 7 on the periodic table, number 53 down here. And we are going to write that out, but we're going to change its suffix to "ide." So instead of iodine, we are going to write iodide. So for our first one, we have potassium iodide. Our second example is NaCl. So we start by writing out our metal first. Na stands for sodium. That's in group 1 on the periodic table. Sodium. And then we write our nonmetal with the suffix "ide" at the end. So instead of chlorine, number 17 on the periodic table, you're going to write chloride. Pretty easy. We have one more example. And this one is Mg Br2. This one seems like it might be kind of funny because we have this 2 on the end, but really that doesn't become a factor until we are given an example where we start with a name and we're writing out the formula. So this one we treat the exact same way. We have our metal, Mg, number 12 on the periodic table, that's magnesium. And then our nonmetal, Br, it's in group 7, number 35 on the periodic table. That's bromine, but we are going to put on the suffix "ide," and we've got magnesium bromide. So that's naming. In the blank space beneath MgBr2 in your notes, it says blank compounds will always end with "ide." That's binary compounds. So in binary compounds, we've got a metal and a nonmetal, and our metal is always a metal with a set charge. And you're always going to see "ide" at the end of a binary ionic compound. So now we're going to do a few examples. We're going to kind of be doing the opposite. We are going to start with a name, and we are going to go to a formula. So we're going to do an example first that actually isn't on your notes. We're going to start out with, let's do potassium bromide. And I'm just going to do this one because it's a little easier than the first example that we get. So potassium bromide, we'll start by writing out our letters. For our metal, we have potassium, that is K. And then we have bromide, which we know to be bromine, and that is Br on the periodic table. So far we have KBr, but we have to make sure that we don't have any little numbers down here under the K or the Br. And those numbers stand for the number of that element that takes that is part of the compound. So to find that out, though, we have to look at our charges. And if you look on your notes, it says positive charges must equal the negative charges. Think least common multiple. So we want the overall charge of this to be 0. Okay? And we know that our metals have positive charges, and we know that our nonmetals have negative charges. So if we look at our periodic table, K is in the first column, first group. It has a positive 1 charge. Bromine is in group 7. It has a negative 1 charge. So if we put parentheses around them, we add them together, we get 0. That means we have 1 of each of these, which means we could put little 1s down there. In reality, we will probably never put 1s down there. That will just, we'll cancel those out, and so you can just write KBr as your answer. So there's an easy example. Your next one that you have is strontium phosphide. So you have strontium phosphide. Strontium is in group 2. Sr is a positive 2 charge. And phosphide, that comes from phosphorus, which is a negative 3 charged particle in group, or element in group 5. P is our abbreviation for that. We have a negative 3 charge. Now if we wanted to add these together right now, we would get a negative 1, which is not good. We don't want our compound to have a negative 1. So what we can do is we can balance our equation out so that we can get 0 at the end. So we're going to change the number of strontiums or the number of phosphoruses that we have in this compound. So to do that, we want to find the least common multiple, which in this occasion is 6. So we can multiply this by 3. We can multiply this side by 2. We get positive 6 right here, negative 6 on this side. And if we add those together, then we get 0. Okay? So that means on this side, for our strontium, we have 3 strontiums, and we have 2 phosphoruses, and there's our answer to our formula. Sr3, P2. Our next example is lithium oxide. Lithium oxide. Lithium is in group 1. We know it has a positive 1 charge. Oxygen is in group 6. It's one of our chalcogens, and it has a negative 2 charge. And if we add those together, we know we're going to get a negative 1. So we can find our least common multiple. In this case, that is 2. So if we multiply this side by 2, we get a positive 2. If we multiply this side by 1, we get a negative 1, or negative 2, sorry. And if we add these together, we are going to get 0. So we know we are good. We've got a good compound here. So we see that we multiplied this side by 2. That means we have 2 lithiums. We multiplied this side by 1. 2 in our 1. We have 1 oxygen, so we don't have to write it down. Li2O is our answer to this compound. In our last example, I'm going to give you a little shortcut. It's called the crisscross method. But we have calcium sulfide. Calcium is in group 2. Its abbreviation is Ca. And sulfur is in group 6, and it has a negative 2 charge. So we've got a positive 2 charge and a negative 2 charge. So for this, the crisscross method, this will give us a quick way to do our equations. But if we write our charges above them, we can bring our charge diagonal across both ways, and that will give us the numbers that go below. So if I bring my positive 2 down to sulfur, I'm going to have S2. And then if I bring my negative 2 across to calcium, what you're going to do is you're going to ignore the negative from your nonmetals, so you're going to have Ca2S2. So in this situation, you have 2 of each. You can simplify, and you can bring this down to 1 on both sides. So essentially, you have CaS as your formula. Example, where you can maybe get a better idea of the crisscross method. So we are going to do lithium nitride. So for this one, we know we have lithium, Li. We have N. Lithium has a positive 1 charge, and nitrogen has a negative 3 charge. So if we do our crisscross method here, we bring our 1 and our 3 down, diagonal across, and we get Li3N1. And if we test out our math, we know that if we have 3 positive 1 charges, we're going to get a positive 3 up here, and if we have 1 negative 3 charge, we're going to get a negative 3 up here. We add them together, and we get 0. So this is a happy formula, a good equation, and if we don't write it with the 1, we just get Li3 and N. It's a bad 3. There we go. So that is naming binary ionic compounds. The biggest thing to remember is when it's a binary, you are only doing the metals that have set charges, and your suffix for your nonmetal is always going to end with an "ide." The next lesson will be covering ionic compounds with metals that have multiple charges. So they will be the metals in the middle of our periodic table.